So now that we know enough basics to run a program, do some math, print out results to console, let's start talking about doing some more complex computations. To do this, it's convenient to talk about operators. This can range from increments in the integers, compound assignments, and comparisons like less than or greater than. This will help us run programs where we might need to check conditions that tell us how to do a computation and so on. So in this video, we are going to talk about assignments first, and then we'll jump into loops and conditional statements that will allow us to do much more complex computational tasks. So assignment is essentially assigning a value to a variable. So if we declare some integer a, an assignment operator would be the equal sign, setting it equal to, say, 5. We also saw arithmetic operators for addition, subtraction, multiplication, and division. One that we left out was the modulo. So, for example, we could print out the value of 15 modulo, this percent sign is modulo in C++, modulo 4. And if we were to compile this and run it, we would see that 15 modulo 4 is equal to 3. We can also do compound assignments. These can be useful to shorten code. So for example, we could take another integer b, let's say, and assign it the value of 5 as well. And then we could write something like b is plus equals to a. So what we just did here is equivalent to saying b is equal to b plus a. But this just shortens the code into a much more compact form, and it just looks nicer. You can do this with any arithmetic operator. So for example, we could also write b is equal to times equals to a, and what that would be is it's b times a, like so. So you can do that with any arithmetic operator. So something that you'll see when we introduce loops is increments, either a positive increment or a negative increment. The positive increment operator is seen as plus plus. So if we set a is equal to 2 here, we could, for example, just write plus plus a here and see what happens. So what this will do is it will increase the value of a by 1. So it's currently 2, and when we print out what happens after plus plus a, we see that it became 3. If instead we also put b is equal to plus plus a, what will happen is the code will increment a by 1, and then assign the value of the resulting of this expression, so that'll be 3, so a plus 1. It'll assign that new value to b. So let's print out both a, and we'll print out b together. And we see that a, which comes out first, is 3, and b, which comes out second, is also 3. Now what's interesting about the incremental operators is that we can actually just switch the side. So I could put b is equal to a plus plus. Now what's going to happen here is b is going to be assigned the value of a, and then the plus plus will increment a. So let's see that in action. So compiling, running, you see that a itself was incremented to 3 from 2, but b was assigned its previous value of 2, so it wasn't incremented. So that's just a little weird thing about these operators. So with that, we can move on to some more fun stuff. Often you'll want to check the truth value of something before proceeding in a program. So a data type that we can use in C++ is a Boolean. So you can declare something like that. We can call it x, bool x is equal to true. We could also declare it as false. So interestingly, something that we should pay attention to is that when we print this to the console, so what would x be if I declare it as false? instead of printing out false, it prints out 0. So this is binary. False will always come out as 0. And then if we typed true, what will happen is it will come out as 1. So 0 is false and 1 is true. So we can now test a whole bunch of things in this context and print out the truth value. So for example, we could check equality. We could check to see if A is equal to B. And the way we would do that is we would ask, is A equals B? So instead of equals being the assignment operator, having two equals there is actually asking whether or not something is actually equal to the other thing. So we know the value of this. We of course know that A is equal to 5 and B is equal to 5. So printing out this, we would expect the output to be 1. So compiling and running, we see the output is 1. So in fact, it is true. We can also do things like, for example, is A greater than B? We know that that's wrong. So compiling, we should get a 0 when we run. And we see that in fact it is 0, so confirmed 5 is not greater than 5. We can ask, is it not equals to B? And in fact, that is false because it is equal to B. So all of these things work like the regular sort of truth table type things that you would see in a math course or a logic course. We can also combine logical statements with the logical and the logical or. So for example, let's write C is equal to, int C is equal to 7. And then we can ask something along the lines of, is A equal to B and is A less than C? So this is a logical and, so it will only give us a true for our variable x if both A is equal to B and A less than C is true. So both of the statements need to be true for this to return true. So printing it out, this was evaluated to true. And for example, if we switch this to A is greater than C, which we know is false, we could output this and we get 0. We can also use the logical or here, and we see that this is in fact true because A is equal to B, and this is false. A is greater than C is not true because C is 7 and A is 5. But the logical or only needs one of the conditions to be true. So if we now run this instead of the logical and, we come out and we see the value of 1. So this is true. Okay, so that was a really quick crash course, but hopefully everything I said was clear. I encourage you to sit down, potentially pause the video here, and play around with everything I just talked about. So let's put some of this stuff into action with if statements and loops. Oftentimes we only want something to happen if a certain condition is met. So as you may have seen in another programming language, we use if statements for this. The way we do that in C++ is we write if, in brackets we write some test, so maybe we write the test A equals B, and then we write a curly bracket region, and inside the curly bracket region, if the A is equals to B conditional is met, so we get a true value inside this test, the code inside of these curly bracket region will execute. So we could, for example, write A is equal to B as our output if this is indeed correct. And let's delete this here. So so we know that A is equal to 5 and B is equal to 5. So this condition will be true and this code will run. So let's compile it here and run it, and it is in fact true. A is equal to B. So if we then changed B to 6, as you might imagine, running that, the code does not output. So oftentimes you also have other conditions that might tell you what you might want to do. So A is equal to B, that's not, you know, the whole sort of like the whole universe of possibilities. So we could also have another condition, like let's say we also have the condition, is A greater than B? And we do the same thing. We put a curly bracket region, and let's just copy this here, and instead we could put out the output, A is greater than B. Now, we could make as many else if statements as we want. That could go on forever, but we could also put the last case. So A is equal to B, A is greater than B. So what's left, that is A is less than B. So we could put another else if statement, or we could just put else. So that's just everything else. If A is equal to B is not satisfied, okay, we don't do that code. The next thing we check is else if. And if that's not satisfied, we just go to else. So every other possible case, we will do else. And here we know that the remaining case is A is less than. So what will happen? So A is actually less than B currently. So if we run that, we get the result, A is less than B. Now note what happened here, right? So if I do something like A is equal to 7, the code that will trigger is this one, and the code won't bother checking any additional statements. So if the if statement is true, it will not bother checking if any of the else if statements are true. So just another side note, I hope you're coding along with me here, typing out yourself, changing things around. That will be the easiest way for you to build intuition and get started on your own writing code that you want to write. Okay, so let's get rid of this code here and let's move on to loops. So loops allow you to do repeated statements basically until some condition is met. In my opinion, the easiest and largely the most useful loop is called the for loop. So let's say I want to print out the first 10 integers. Well, of course, I could just write out cout for every single one of them, or I could use a for loop. So for, so the syntax is the following. So I write for int m, and I will start m as equal to 1. So notice this is a declaration. I just made a new variable called m. And then I put a semicolon. And then I want to go up to the first 10. So I could say, we want to go until m is less than or equal to 10. And then I want to increment by 1. So I'll use our new fancy m++ here. We could have also just used m plus is equal to 1. But we just want to increment by 1 because we want all of the integers from 1 to 10. And then what we'll do is we will just print out each one. So doing that, we see that it printed out 1 through 10. We could, for example, also just do increments of 2. So if we did increments of 2 or anything else, what happens if we just do 2? Well, you see that it goes up by 2, 1, 3, 5, 7, 9. So the way this code is working is that the first loop it will go through, or the first step it will go through, is it'll assign m is equal to 1. It'll do the code. Once it gets down to the end of the for loop, it'll go up and it will use the rule to increment m. And then it will test to see if m has reached this and made this false. So we'll see 1, it goes down, it prints 1. It then increments by 2, you get 3, and clearly 3 is still less than 10. And it keeps doing this all the way until you get to 9. Now when it prints 9, it increments by 2, and you get the value 11. And then clearly m is now greater than 10, so it ends the loop. So now let's accomplish this with another loop. There are more than just these 2 loops, but these are the 2 loops that I use primarily. You can definitely look up online if you want to explore the other ones. But while I write code for this series, these are the only 2 that we're going to use. So the next loop is called the while loop. The while loop is a little simpler. So I'm just going to write int m and declare it outside of the loop. And the while loop just takes a single condition. So the condition that we'll take, again, is m is less than or equal to 10. And the while loop also has this curly bracket region. So going from here, we could do the exact same thing. So m is equal to 0, and let's just print out 0 through 10 again. Well, I guess we'll be including 0 this time. So if we do this, I guess it's a little bit more transparent what the while loop is doing here. So we declare m is equal to 0, and then we print out m. But we now have to manually change it for ourselves or declare it inside of the loop. So we could write m plus is equal to 1 here, and then it'll basically do, and then it will do exactly what the for loop did. We just had to throw in the declaration and the increment in manually ourselves rather than being part of the loop declaration. Here we'll see m starts at 0, and then so it asks, is m less than or equal to 10? The answer is obviously yes, and then it just goes through and does all of this stuff up until m is equal to 10. So this is all pretty straightforward, I think. The while loop is really useful for situations where you might not know how to structure the loop as a for loop per se. So in those instances, I use the while loop, and we'll definitely get into examples where the while loop will have advantages over the for loop, and the for loop will have advantages over the while loop, but they're largely generally both applicable in every situation. So in this series, once we start coding examples up, we are going to want to do as little work as possible to compute the quantity we are interested in. So sometimes we might want to write a loop, and we might have a condition that if it's met, we want to end the loop early, or we might have a condition that makes us want to skip a specific iteration of that loop. So to do this, there are things called jump statements. So let's make an if statement that triggers if m is equal to 5. So inside this, we're going to test the two types of jump statements. The first one is going to be break. Now the break statement is going to just end the loop completely. So normally if this wasn't here, we saw that it would just print from 0 to 10. Now the break statement is going to end this when we see that m is equal to 5. So if that happens, we won't print out m is equal to 5, right? So running this, we see that the break statement ended the while loop. So once m was equal to 5, this was triggered and we didn't print out 5. So break is really useful for circumstances where once a certain condition is met, no more work needs to be done. Anything after that would be a waste of resources and a waste of time. So now let's move on to the continue statement. Sometimes you'll be in a situation where there are just certain situations where you just don't want to collect data. It would just be a waste of time to spend resources and time computing whatever m is equal to 5 corresponds to. So for that, we can use the continue jump statement. So when we write continue here, what it will do is it will just end the current iteration of the loop. So it will send the code, the code won't go past this point, it will send the code back up to the top. So right here we have a problem in our code, because if we skip m is plus is equal to 1, then what will happen here is this will then send us back to the top and then go back down, and it will trigger m is equal to 5 again, and we'll create an infinite loop. So we actually want to increment our m before. So running that then, what we'll see is that the code will just skip, we'll delete that, the code will just skip m is equal to 5, and it'll print out every other statement. And of course, we're going to miss the m is equal to 0 here, but that's okay. That can be changed in other ways, but it's not useful for the example. So what we'll see here then is that we go m is equal to 0, we add 1 to it, so it's 1. This is not triggered, so we print m. Now we go through 1, 2, 3, 4, and then we're missing 5, because as soon as m was equal to 5, we said, okay, we don't need what happens after that, just go back to the top, and then we increased to 1, and we got 6. So as we get deeper into this series, it will become more and more important to think about using things like jump statements or any other method we can think of to cut down on the number of computational steps taken. Coding larger algorithms can sometimes be an optimization problem of memory commitments and the total amount of time or operations that need to be taken to actually execute the code. But that's it for today. Stay tuned for the next video where we will put these ideas to the test and we will calculate pi.